equation with tangent line is, I kind of talk about it like blank times x minus blank plus blank. And we're just filling in 3 slots. One of the slots you got to find the derivative and plug in a number, and that slot can just get harder. That's the only difference. This is just the x value. This is the y value, which sometimes they don't give you. And if they don't give you that, you plug x into the original. And then what's this one? Slope. So you plug x into the derivative. So like that's not a difficult concept. We did these before, but at that point we were taking the derivatives of like x squared, like 4x plus 1. And so taking the derivative and plugging in a number to find the slope was simple. So the only thing that changes is now the derivative could, now your equation might be like cosine of e to the x. Now you take the derivative and plug in. So it's the same concept. It's just this step gets harder because we know more ways to take derivatives. You know? Yeah, should I do an example? All right. So let's say y equals, I'm not going to do like a complex one because they're just too hard to make up in my head. But you can I show you these? I'll show you these. This is your review. 100 questions. It's supposed to be good, right? It's supposed to help you. Like if you know everything in here, you can do this, you should kick ass on the test. Basically, that's it. You can do it twice.
Can you do that twice?
You can. I mean, so yeah, I just went through all the topics we did and started grabbing questions on my computer and putting them on here. I'll give you time to work on this class, ask questions. Yeah. I thought more questions, I thought it was less, just to make sure we cover everything. You're not responsible to do it, like I'm not saying go ahead and check, but we'll check your tests. So hopefully it'll help you. So let's say y equals, I don't know, I'll do like, let's say cosine of 3x. And I say find the equation of the tangent line at x equals pi over 2. Oh, that's bad, yeah. Whatever, that's fine. Okay. So as soon as I see find the equation of tangent line, I'm just starting here. Setting up that basic. Get my slots ready. X value goes here, so right away I can just put pi over 2 there. Y value goes here. So to find the y value, I plug into the original. So this is cosine of 3 pi over 2. So pi over 2 is 180, right? So 1, 2, 3 pi over 2 puts us over here. From your perspective, I think. So what's the x value there? Cosine's x value. So what's the x value? -1. And then here you plug x into the derivative. So the derivative of cosine, and this is like we couldn't do this problem last time we went through tangent lines, but now we can. So what's the derivative of cosine? Negative sine 3x times 3, because the chain rule, right? I think a lot of you guys notice, I think, this is just so easy to forget. Like, I think most people in here at some point on one of their gateways forgot a chain rule. It's just so easy to overlook that. So you just got to always be, I wish I had a better way to say that. You just always got to be aware of it. Then I plug in pi over 2. So negative sine of 3 pi over 2. The sine's the y value, right? So, from your perspective. So, 1 pi over 2, 2 pi over 2, 3 pi over 2. What's the y value over here? It's 0. So that would just be 0. And then this would be the same as like y equals -1. Is that process familiar? I mean, it's been a while since we've done it, but hopefully it's okay. What if I said find... Sorry, I just asked a question on my third time. Is that process okay? Yeah.
So I'm just like wondering, so on the test, you're responsible for knowing like what 3 pi over 2 like cosine equals.
Yeah. Yeah, that unit circle that we did before, like that's... You just gotta know that. I wouldn't say the majority of the questions on the test would have that, but there'll be a couple. Any other questions? Okay. What if I said find the normal line there? So I want to do this example because it's a little bit of a goofy one, and then I'll put the directions for normal line there after. Find the equation of the normal line. Same idea. It's a y equals the same problem. Cosine of 3x at x equals pi over 2. So you start off with the same process. I know some of you can see what I'm getting at already. Don't give away the ending. What normal mean? Perpendicular. These two are the exact same. So this is still pi over 2. This is still the x value. This is still the y value, so -1. The only thing that changed is now you plug x into the derivative here. And then what do you do with that answer? Flip it over and flip it around. So flip it over and change the sign. But my slope up here was 0. So this is like a special case I want to just point out. The slope up here was 0. So if you flip over 0, what do you end up with?
Undefined.
You end up with undefined. So what kind of line was this? Don't say straight.
Straight vertical.
What kind of line was this one?
Horizontal.
Horizontal. So when I'm perpendicular, that's vertical, right? So that makes sense. It's got an undefined slope, you know? So at that point, I'd be like, well, wait. I can't do that because vertical lines are x equals a number, not y equals. And the only x value I have is that pi over 2. Hey. Done. Okay. Okay, well with you. That's not very good. Okay. Question on that one? So let me do the normal line notes then. So normal line, I mean, same tangent line except for that last step. So I'd still do this y equals blank times x minus blank plus blank. That's the x value. That's the y value, which you get by plugging into the original. That's the slope. Same. But then this is just one extra step, so it's plug x into derivative. Then use the negative reciprocal. So like this last one, I'll go back to the screen in a second, but this last one, if the slope came out to be like 3/4, when you were doing the normal line, what would you put? -4. So that's the only difference. When it's 0, it's a little goofy because you get the 0 undefined thing, but other than that, you're just flipping the number over and changing this. Alright. Those two okay? There was also horizontal tangent lines. So for those, you set the derivative equal to what? Equal to 0. Then solve. So horizontal is the slope of 0. Derivative tells us slope. So we take the derivative and set it equal to 0. So I'll do like a simple example, and these don't get complicated. I wouldn't expect any like e to the cosine of 4x squared, set that equal to 0. That's a little bit unreasonable. But I can give you like a product rule, a quotient rule, like those type of things. So let's say like y equals 3x minus 6 to the 3/4. So yeah, last time we did this, the only thing we know to take the derivative of was like x squared, x to the third, x to the fourth, so it was easier. This isn't that bad though. So if I take the derivative here, 3 over 4 times 3x minus 6 to the negative 1/4 times what? Times 3. And this is actually the reason, or one of the reasons, that I told you guys to get rid of negative exponents and kind of like catch you in the habit of it. So if I get rid of negative exponents here, this would be a 9 on top because 3 times 3, the 4 on the bottom. Then you've got this 3x minus 6 to the 1/4 on the bottom. So if you want to find horizontal tangent lines ever, you have to move the negative exponents to the bottom. So you've already kind of got that step in your back pocket. You know, now we can move forward from there. So take the derivative to equal to 0 and solve. I'm getting ahead of myself. So if you want a fraction to equal 0, go on the top to equal 0 or the bottom? The top. So when does the top equal 0 here? Never. So there's no horizontal tangent lines. So you go 9 equals 0. Okay, that doesn't happen. No horizontal tangent lines. This won't be in your test because we haven't quite gotten that far yet, but I can also find a vertical tangent line here too, right? The vertical slope, we just have the top or the bottom equal to 0. Bottom. So couldn't I just set that equal to 0 and solve? So at that point, this is why I had you guys make them for the fractions, because now we can work with the top and the bottom separately. Is that okay? Questions there? I believe that's the only 3 things. Let me just double check. Oh, I want to do a couple graphs. Find the slope of a function. What do you do for that? Take the derivative, then what? So you just plug it in, right? Yeah, let's look at a couple graphs. Just, it's been a while. So like say I give you this graph and ask you to sketch a graph of the derivative. Do you want a second to try it, or should I just go through it? First person to speak gets their way. Give me a second. Thanks.
you.
Yep. Yep. So you have a second. If you don't want a second, just deal with it. Wait until I do it. Remember the wiggle thing? How many wiggles is that? 2, so your derivative should have 1. The reason for that, you might understand this better now, is that's an x to the third function. So when I take the derivative, it's going to be an x squared function, right? Because like you lose 1 from the power. And then when you go from x to the third to x squared, you lose a wiggle. So I would start with, the slope is, remember the derivative is a graph of the slopes. So the slope is 0 right there. Like the guy on the surfboard would be flat right there. The slope is 0 right here. The guy on the surfboard would be flat right there. And then it splits your graph kind of into sections. So in this section over here is your slope, positive or negative. It's positive, so your derivative graph has to be above the axis, but it's also got to be 0 by the time I get to there. So I'm coming down, and I know it's going to be like a one wiggle or a parabola, so I'm kind of starting to make that shape. In this middle section is my slope, positive or negative? Negative. So my y values need to be below the axis. The derivative needs to be below the axis. And I know I got my parabola shape again. If you want to get really intense about this, and you're not responsible for this for the test, but that slope is the steepest right there. You see how it turns from like an upside down U to a regular shaped U, like right there? That's where the bottom of your parabola should be. We'll do more of that in a couple weeks. And then this last section, our slope is positive, so we need to be above the axis and kind of keep our shape. So that would be my f prime. You guys remember doing that? What? Did you say yes or no?
I said yes.
Okay. Should we do another one? Okay. Try this one. So that's got 3 wiggles, right? Agree?
Yes.
So your derivative should.
I mean, who wouldn't take a video of him found out? Seriously.
So I would start off again with, I know the slope is 0 there, I know the slope is 0 there, I know the slope is 0 there. Kind of splits it into parts for you. And if it's got 2 wiggles, it's either going to be that or that. Like you just got to try to figure out which one. Basically, once you know where to start, you can kind of do the rest of it from there. But my slopes here are positive, so my y values of the derivative need to be above the x-axis. Slopes here are negative, so I got to be below, but I got to come back by the time I get to there. Positive, so I'm going to be above, and then negative, so I'm going to be below. So that would be your f prime there. Questions on that? So this is what I mean. Like I didn't really show you anything new right there. Like it's probably helpful to review. I'm not saying that, but there's no new material on your test. We kind of did some stuff. Then we did a bunch of derivative stuff, and now I'm just packing that all into one big test. Does my sketch help? Pretty effective, right? I do want to talk about the first time you guys took the gateway. It's kind of scary. So in previous years, I have not. I don't know, maybe I did something different. Maybe it's you guys. Maybe people are. I don't know what the case was, but in previous years, I have not like gone through and done like a full video walkthrough of the first 2. I kind of feel like I dragged some of you through that gateway, which is fine. That's my job. I'm not like criticizing you for that, but I feel like some people didn't prepare enough for the first one, which maybe because you have 3, you don't necessarily do. I just want to caution you that there's not 3 of this one. So whatever, because I know some people work their butts off to get from what they got in the first gateway to the second or the third. You don't get to like not do well on this one and then work your butt off. So work your butt off beforehand is what I'm trying to encourage you to do. You know? I'm not saying people didn't work. I'm not like accusing anyone. I'm just saying you get one shot at this. It's not like the gateway you get more. So I feel like. So, is that a fair enough statement? Okay. Some of you have seen this, some of you haven't. This is 100 questions. It is multiple choice, so that'll help you kind of get into like the format version. Your test, I don't know yet if it'll be multiple choice. I haven't quite got that far. But I had it do like the step before the answer and the answer, so you can kind of see both. I think that helps you guys like with the format of it. And yeah, I'm gonna give you time in class to do it. I'm planning on giving you. I might do some things with you the next couple days to kind of help you do some other help review also. But basically, you have time in class to do this. So, yeah, that's that. If I can lift these up. I feel like it's not huge. So you two, I don't know if you want to if you do better on this next test than you did on the gateway, I'll bump your grade up straight away. So like if you get a 7 in the gateway, you get a 90 in this. You get a 90 in this and in this. So I'll go back and like bump that. And it can't hurt you. Like I'm never gonna pull anything down. Basically, if you prove that you know it, then I'll find a grade for it. What? 34 pages. There's supposed to be room to work. That's like what I was going for. But then that took up a lot of paper, so I don't know if that's looking bad. You gave me room to work, but I killed some trees. Seriously? Oh.
Hers are just longer than everybody else's. They're better than everybody else's.
They are.
I do have extras in case there's anyone that's enough of a what's that, a masochist? Not someone that likes torture.
Oh,
To do it twice. That's what I was going for. Did I say the wrong word?
No, it makes sense.
Alright.
That was very experience.
That was what you were
I
going
didn't
for.
know like the context.
You should.
It's split into like different parts. So one thing that might be a decent idea would be to do like one from each section the first time through. And see how you're doing, check those, and then go like so do number 1, number 5, number 9, you know what I mean? Like do one from each group. And then go back and do one from each group again, and then go back. I think that might be a good way to do it. It's up to you how you do it. Basically, the idea is if you can do everything on there, you should do really well. So I'll try to get you. And then if I can help, if you want me to go through questions individually, after school, on the board, with everybody, whatever,